Hello, everybody. Welcome to WebAssembly Unleashed, your source for news and views about the world of WebAssembly. As always, I'm your host, Joel Moses. Alongside me, my fellow WebAssembly aficionados, Oscar Spencer and Matt Yakabuchi. Hey, guys.
Hey.
As you know, here on WebAssembly Unleashed, you are in for what I can guarantee is going to be an exciting, engaging a piece of entertainment and a podcast about WebAssembly. Sit back and relax. We're going to talk about WebAssembly and a very special topic today that's near and dear, I know, to several hearts on this. I'm super excited about our WASM community guest today. He's become kind of a familiar face around the office as of late, but before we introduce him, let me first introduce my compadres, Oscar Spencer and Matt Yakabuchi. Welcome, and it's time to talk about what's interesting this week. Anything you've spotted?
Yeah, well, one thing, back in March, Zig 0.140 came out. They released that, and among many improvements or many changes, WebAssembly was highlighted. I'm going to go out of my depth if I talk about it too much, but yeah, it's pretty interesting to see that they committed to WebAssembly early. They have a target for WebAssembly, and they're sticking with it. They're continuing to improve.
Yeah, I don't know if we've talked about Zig on the show just yet, but it's a really interesting project, and I love that they dove headfirst in on WebAssembly and have been doing that for a long time. So it's exciting to see them continue to keep things moving forward. I've got friends who are excited about it, friends making the component model happen for Zig. So it's really exciting to see these improvements keep on coming out. So that's awesome.
Yeah, that's really cool. Oscar, you got anything this week that you've looked at?
Oh, just, everything continues to be busy. So we're just continuing to move forward in the WASM world. Hopefully, maybe by the end of the summer, we're going to see some exciting announcements for WASM, but I'll keep my lips sealed for now.
Okay, sounds good. The one thing that I looked at this week, did you guys see Linux PDF? So
No.
this is loosely WebAssembly associated. It uses an earlier version of Vimscripten, but somebody figured out that you can actually compile some things down to an ASM.js carrier and actually run Linux inside of a PDF file.
Oh
my goodness!
Yes,
like in terms of true portability, that's really stretching the bar there. As you guys know, we have one of our compadres on the Nginx team that came through Adobe and actually was the maintainer for a long time of the PDF standard, and so I had to send that one to him.
I mean, it's a portable document. Why not port, Linux?
It ported right inside of there. All he sent me back was one word: sigh. I think that says it all.
Excellent.
All right. Let's introduce our special guest. Let's bring him on. Nick Fitzgerald, one of the heavy lifters of the WebAssembly community, constant contributor to WASM Time and Crane Lift, Mozilla alum, right? JavaScript expert. I could go on forever, but it'd just get ridiculous. Welcome, Nick. Thanks for joining us today.
Hi. Thanks for having me.
All right. The topic we've chosen for today is kind of a funny one to, I guess, the uninitiated. We're going to talk about garbage collection today. For the folks that aren't necessarily familiar with what that is, why don't you explain to us what garbage collection is as a concept?
Yeah. So, you're writing programs. You're creating objects that reference other objects and all that stuff. And the role of a garbage collector is to identify when objects are never going to be used again and then sort of recycle that memory. In languages like C, C++, you're doing manual memory management. You allocate something and then you have to remember to free it at the right time or else you get a memory leak. With JavaScript and now WebAssembly, you can opt into garbage collection where you just allocate the objects. And the way that garbage collectors typically kind of look at this problem is as a graph problem. So if you have this object and then it's got a field that's referencing this object, we would kind of treat these two objects as nodes in a graph. And then the references between them as edges. So garbage collection kind of starts from, what are all of the, global variables, things that you're actively using right now and treat those as roots. And then kind of do find everything that's transitively reachable from the roots. And then so that's all the stuff you want to keep. And then everything else can be recycled and used for, new objects that you create.
So Nick, let me just ask you, I want to see how much of a purist you are when it comes to topics like these. So obviously there's tons of different algorithms for collecting garbage. And one that is sometimes a little controversial is whether or not it is considered garbage collection is reference counting. And I'd like to know your opinion. Do you consider reference counting to be garbage collection, or do you say, you're not good enough to be a GC?
I do consider it garbage collection. That's if you read the academic literature, it's considered garbage collection. And then sort of the way that you divide these two approaches is you'd say there's reference counting garbage collection. And then what I described earlier is really called tracing garbage collection. And there's a very cool paper called The Unified Theory of Garbage Collection. And I cannot remember off the top of my head who the authors are. I'm sorry. But basically they say, they were some heavy hitters that I think like IBM, like working on GCs for JVMs and things like that. And as they were coming up with these different algorithms for speeding up garbage collection, they realized that they were sort of just kind of combining tracing garbage collection and reference counting into, more and more different ways. And then they kind of put out this paper, A Unified Theory of Garbage Collection, and it's fantastic. I like that paper a lot.
Awesome. And, for our listeners, I just really want to underscore how important garbage collection is as a concept.
Mm-hmm.
Probably your favorite language out there relies heavily on garbage collection. If you write JavaScript, if you write Python, if you write any language where you don't have to free the memory yourself, you're probably relying on a garbage collector. So this is something that's just so pervasive throughout all of computing as it stands. And so the fact that something like this is coming to WebAssembly is a huge freaking deal.
Or you should double check the size of your programs. They might be getting a little big.
Oh, yes.
Yeah. Yeah. So what's driving the push to get garbage collection in WebAssembly right now? I mean, is there something pressing out there in the community that's really causing us to look at it at this stage, or is it just the next phase?
Yes, and so I mentioned, C, C++, Rust, these languages that do manual memory management, maybe use language features on top of that to kind of make it easier, but don't use garbage collectors. And so WebAssembly, before the GC feature is very, well adapted for them because you have one or more linear memories. And it's just byte addressable, and that's sort of the way that those languages work, and so everything just works out fine. But then, when we start talking about JavaScript, Python, Java, Kotlin, OCaml, Scheme, etc., all of these languages that really don't talk about memory as like this one, giant byte array, byte addressable region, and instead really talk about objects that reference each other. Then your options for bringing those to WebAssembly were basically to include a whole runtime that implements a garbage collector and all of that stuff, and then compile that into the WASM and ship it along with your program, or potentially into a separate WASM module so it can be reused. But either way, you're shipping this probably fairly large runtime.
In the case of JavaScript, literally carrying the monkey on your back, so to speak.
Right. So that's sort of one side of it is that this lets languages like that target or basically leave their runtime behind and start leveraging the WebAssembly runtime itself. And the other thing was that, WebAssembly comes from the web, right? And browsers have spent years building these very, high-tech engines for running JavaScript and collecting JavaScript's garbage. And now they also run WebAssembly, and why not also let them use that garbage collector, right?
I see.
Yeah, this is something that's pretty near and dear to my heart. As a language implementer for WebAssembly, I can almost tell you that nearly every single bug we've had in the compiler had something to do with the garbage collector. And it's always, okay, cool, I get to go debug the GC yet again. And then sometimes that bug results in, I get to rewrite the entire GC. And I guess that's my weekend is doing that task. So I, for one, am exceptionally excited about being able to flush all that code down the drain.
Right. Well, Nick
It'll just
and
be
Oscar,
my problem now instead of yours.
Yeah,
that's
exactly.
right. Well, Nick and Oscar,
you get smarter engineers to do the work for you.
So to hear you guys talk about that, I mean, there's a little religion behind different approaches to garbage collection, but I mean, to hear you talk about it, Oscar, what makes garbage collection implementation so difficult? I mean, you guys described it in roughly 45 seconds, both modes that we talked about. What makes it hard?
I'd say the thing that probably makes it the hardest is trying to optimize, because in general, the general concept isn't that hard, right? Like if you're talking about like a classic mark and sweep GC, right? Okay, sure. Let's just go look at the stack. Let's see what all the live objects are. We can trace them. And then anything else that is on the heap that's not there, yeah, just throw it out. Easy peasy. But then when you start thinking through, well, we have to, for that kind of system, it's called a stop the world GC, where your program's executing, and then at some point in time, you must pause all execution and then go do all of your cleanup, right? And that's bad for real-time systems. Like that's pretty bad. It can have unexpected behavior for users' programs, things like that. So we have an incentive to go optimize these and make them fast, maybe make the pauses way shorter, or potentially, for us, we have a reference counting GC. And so it amortizes all the GC because it's happening sort of all the time. But even still, it's like, okay, counting references, you have to increment references and decrement references. That's a lot of compute time. And so if we can do little optimizations to get rid of times that we have to incref or decref something, we actually gain a lot from that. And so in the quest to wreck those optimizations, sometimes you forget an incref somewhere. And then it's like, accidentally freed this object, but the user still cared about it. And you run into a lot of problems that way.
This brings up a question that I have is, so WebAssembly garbage collection, does that enable the higher order language garbage collection? So, okay, I am language X and I'm a reference counted GC, and I'm language Y and I just want to do mark and sweep. Simple, easy. Now, does WASM have an opinion, or is it just enabling either method or multiple different methods for that matter?
Yeah, so rather than kind of exposing building blocks for WebAssembly programs to build their own garbage collectors, it's a bit higher level than that. It's saying, here's a way of defining objects, either structs or arrays, and then given that you've defined them, you can now allocate them, and they can reference other things. And so the exact algorithm being used to collect garbage by the engine is that's fully an engine concern. It's not a toolchain or WASM producer concern. And it's also, ideally completely opaque and they don't ever learn about it.
And so this is actually pretty interesting, right? Because there's there are good things about that and there are bad things about that. So the good thing is, hey, it's not a concern of like the languages. It's just this WASM module. It's going to run. It's going to do whatever. And so like that's a great thing. But then if you're a user and you craft this WASM module, you might actually care about what the algorithm is for like the thing that I just said now. So think about there's a robotic arm that's trying to do something, and it turns out the runtime that's executing the WASM there is one of those stop the world garbage collectors. That might actually be an issue. Or think about something worse. Imagine there's a car driving down the road and it uses WebAssembly. And then we actually care about how the GC runs, and so the user gets less control over that. But ideally the user has control over the runtime, and the runtimes can then choose, okay, this is the appropriate allocator for this. So one of the things I think about a lot is, okay, let's say you have some, function as a service platform. Probably the executions are really short-lived. And so in terms of choosing a GC algorithm, that means you can have the same WASM modules that, do whatever, but then the actual runtime can say, I'm just going to have a bump allocator. like the best GC is just exit, right? Like let the program run to completion and then throw it all away and you're happy, right? But then you have the option too of, hey, here's going to be a long running process. I can just choose to use a different GC implementation for that process. So it's going to take a little bit of, configuring, on the runtime side. But I ultimately think that is better in general. I think it is better to leave it up to the runtime. So you can say, hey, like the way we have a ton of different runtimes now for different use cases in WebAssembly, it's the same exact thing. For your particular use case, you choose the right runtime that's choosing the right types of algorithms for these types of
So if let's say I start with Go. Go is my language of choice, and I'm compiling that into WebAssembly. I'm not bound by the Golang's runtime GC. I am going to be bound by WASM time or WASM Edge or the WASM layer runtime.
That's correct. Yeah.
So outside of performance, and you both mentioned performance of the collector algorithm. What is religious about the choice of how to implement garbage collection? I mean, is it just the performance of the collector itself, or why do people get so wrapped around the axle on one method over another?
I would say it's because it's largely out of most people's control. And so it's easy to kind of lay blame and get mad at someone else, right? If you're writing a website and you're seeing, that as you scroll, it's kind of like janky because, and then you profile and it turns out, there's a bunch of garbage collection going on, right? And it's like that browser should probably have a better, lower latency collector. But also, like, the reason why it's collecting garbage is because your program allocated a bunch of stuff.
Your program is creating garbage.
Yeah. But to jump back to the unified theory of GC paper, because it kind of ties in here a bit, is like, the reason people reach for reference counting is because it has very low latencies, right? You're only ever really pausing for as long as it takes to do like one object, or how maybe you have like a linked list where like this thing references this thing, references this thing, references this thing, and there's they're all at one reference count, and you drop the root of the list, and then that drops the next one, and etc. Right? But like you're sort of bound. The amount of work that the GC is doing at any given time is based on like what is the object that it's dealing with. Whereas, and so that means that generally you have very low latency. And then the flip side of that is the tracing collector is every time you do GC, it has to scan the whole live set, which is potentially the full GC heap if there's no garbage, right? If everything is live, which means you pausing the program for a long time, right? And so it's very high latency, which is not good, and that's going to give you that bad scrolling. But what it does mean is that it doesn't have to run any extra code in the middle of the rest of your program, right? When the collector is not running, it's not updating, reference counts, increfing and decrefing. Whereas when you're doing reference counting, it is doing all of that. And so the throughput is actually much better for a tracing collector. The throughput in terms of like, how much of the actual program are you getting through? Whereas it's much worse on reference counting. And so what you start to do is you say, well, how do we take a tracing GC but improve its latency? And that's where you say, we'll bring in some of the ideas from reference counting into a tracing collector. And that's sort of what like a nursery is in a generational collector, that involves keeping track of edges from kind of the tenured heap to the nursery so that you can collect just the nursery. But that act of like recording those edges is basically a reference count. And so you start to get these hybrids. And so, as with most technical things, people probably shouldn't be too religious about stuff because it turns out that different situations call for different trade-offs, and the best thing, pulls from both sides, right?
So as we move forward into implementation of garbage collection for WebAssembly, what is the most difficult thing you think you're going to have to deal with?
In terms of implementation?
Implementation.
Yeah. Well, if you'd asked me this a year ago, I would have said writing the actual collector and tracking down, heap corruption because, we forgot to trace some edge in the heap graph, let's say, and then we collected something that we thought was not live, but actually was still live. And then, this resulted in lots of garbage and stuff, right? I don't think that's actually going to be too bad. What's been surprisingly difficult has been getting the type system implemented correctly, because it's not the GC proposal is not just now you have GC. It's got to kind of define what does it mean to define a type, and what types can reference what other types. It defines like a subtyping relationship. So you can say that like, I define an animal struct, and then I define a cat that's a subtype of an animal, and a dog that's a subtype of an animal. But then cat and dog aren't, something you can swap in and out, all of that stuff. And it's using this, I think it's fairly novel variant of what's called an iso-recursive type system. And so the idea is that you can have an object that has references to itself, right? So like maybe an animal has a parent animal, right? And so that's another animal. And so in WebAssembly before this, types could only reference types that were defined before them, right? So you couldn't have a type that referenced itself. You couldn't have a type that referenced a future type. And so that meant that just by construction, like all type references were acyclic. And now they're cyclic. But also, this is sort of where it gets more complicated, is if this WASM module defines, this cyclic type, and this WASM module defines the same cyclic type, we need to kind of unify those so that they can pass those instances of that type back and forth to each other. And so we need a way to like recognize that those are actually the same type. And it involves like some canonicalization and some hash consing and all of this stuff. And that was surprisingly hard to get correct.
I totally believe that. Looking at the like actual specification and looking at the type hierarchy, it's like there's actually quite a bit that's in here, and not to mention like there are concessions that were made in the type system. Maybe that'll be lifted in the future, but like one of the ones I can think of is right now you can only have one subtype, like a one user defined subtype of a type, right? And like that's fine, but it would be kind of nice to have more subtypes.
The other way, right? So you can, one type can be subtyped many times, but each type can only have one super type, one parent type. Yeah.
So for object-oriented languages where you can have deep hierarchies, does that translate? So for instance, like Python, where I can have mixins and subtypes and superclasses, and it can get very messy. Do I have to flatten that to be compatible with the WASM?
So there is a limit on the depth of subtyping that you can do, but I think it's like 64, so you're probably not going to hit that. So that should be fine. But the thing is, Python, if I understand correctly, does allow for multiple inheritance, where you say, I'm inheriting from this class and this mixin or whatever. And that's where stuff starts to get a bit trickier. And you're going to have to figure out how to, adjust things. And when I say you, like it's probably not you writing programs. It's the you of like whoever is writing the Python to WASM toolchain is going to have to figure that out.
So I need to do one of my favorite things in the world right now and put Oscar a little bit on the spot.
Oh boy.
So Oscar, as the chair of the new chair of the TSC at the Bytecode Alliance.
I'm not the chair of the TSC.
I'm sorry.
I'm the director.
You're the director. That's what it's called.
Everybody
the director.
gets a title in the TSC.
Everyone gets a title. You get a title. You get a title, and you get a title. So you've seen the garbage collection proposal as written. What are your thoughts, both positive and negative, about the proposal?
I think in general, it's a huge positive. One of the things we as the Bytecode Alliance care deeply about is continuing to expand WebAssembly to the rest of the world. The huge thing that we get with the GC proposal is, all those big GC languages. So one of the biggest is Java. And so this dream of saying, hey, we can run Java efficiently on WebAssembly is massive. The influx to the WASM community that we'll see from this is something that cannot be understated. So we're exceptionally excited about the ability of the garbage collection proposal to bring these new languages into the WebAssembly ecosystem. So we ultimately think it's going to be a huge, huge boon overall. I have my own personal old man complaints about the GC proposal that aren't particularly relevant to that, but I think overall it's a huge positive. In fact, actually, if you remember way back in episode, I don't know the number, Tabitha, please flash the episode number on the screen. But we had Gilad Baraka on the podcast, and Gilad is known as the father of Java. He was the lead engineer on the Java specification for 10 years. But outside of that, he also works on other languages that do really interesting things with objects at runtime, just changing the shape of those objects. That's something that just isn't even remotely possible with the WASM GC type system. You just can't do it. You can mock it, right? Like you can, and so this is actually something that I'm looking at right now in my own language implementations of not necessarily trying to change objects at runtime, but changing your types to be a little less efficient by just saying like there's an any type in GC of like, oh, this could be anything. And so you're going to get a little runtime cost of that, because then when I say, hey, I'm going to downcast this to the concrete type, well, one, I'm losing type safety by going with this approach. And two, then at runtime, the runtimes actually have to validate that all my casts are correct, which sucks a little bit. But doing that does allow you to say, okay, this object maybe has an array of a bunch of other objects in it. And so if I want to extend this at runtime, I could just add objects to that array. But that's not the most efficient way to do it, right? It would be great if you could just have, this type that I'm like, I'm just going to casually change this type at runtime and the GC figures it out, right? So those are things that like Gilad is thinking about because of the types of languages he likes to hack on.
Well, to bring Nick up to speed, Gilad is really passionate about a concept called local first computing, where you actually divide apart and do a lot of the heavy lifting right there on the client, and you connect the types of the back end and the front end together directly, and you can change things on the fly between these two integrated components, and it's fascinating. But from a garbage collection perspective, it demands a whole lot of other things be present, and so. Anyway, he's very passionate, and I am curious to hear what he thinks about the garbage collection proposal for WebAssembly. But that's another show. That's another show entirely.
It's another show.
What about a negative? Is there something that is not in the proposal that you had hoped would be there? That's to both Nick and Oscar.
I don't know, Nick, if you've got some ideas.
I guess I would just kind of give some framing to what the proposal is trying to provide and sort of what it's not trying to do. So I believe it's Andreas has this saying, Andreas Rosberg, who's been editor of the spec for a while. I don't know if he still is or not.
Oh, yes.
Yeah. He has this saying, he says, as low level as possible, but no lower. And so the idea being that we want to, give people as much like raw access to what the actual underlying hardware can do, right? Without providing abstractions that sort of bake in assumptions and cost overheads and things like that as much as possible. But what we won't give up is safety. So WebAssembly is used in browsers primarily, and also outside of browsers in areas where you don't trust the code that you're running, right? It's given to you by a random website. It's given to you by, a random customer, but you can't have it interact with any of the other customers' stuff, right? You need to make sure that every sandbox is sandboxed and not splashing on the outside. And so the GC proposal is basically like, what is the minimum that we can do to give people access to performant garbage collected objects without adding any more assumptions on top of that, right? And maybe there was a different way that was overlooked I don't know. I'm not aware of any way, but this is sort of an attempt at that. And so the idea is not necessarily that these objects are things that would directly reflect your source program's types, right? When you write a type in your source program, that doesn't necessarily mean it's going to be a type in the WebAssembly. But what it does mean is that if you want to do this stuff like have these more complicated object systems that have prototypes or are swappable in and out, you might not have that out of the box with what WebAssembly GC gives you, but you should be able to build it on top, right? And it should be something that you can build as performantly as possible, given that we will not ever give up safety in terms of the sandbox.
Yeah, and I'd echo quite a bit of that. It's like my complaints with WASM GC, the things that I want to build on top of it, like I can. There's nothing stopping me from doing it. And in fact, I've even spec'd out some of the ways of doing it, a more complicated way that gives me more satisfying types in the WASM type system. And so it's totally possible. It's just a lot more work on my part. And potentially like things like compiler optimizations. So the thing I just mentioned, before of saying, oh, I have to do these downcasts that incur me a runtime type. It's like, well, actually, I could just do some, full program analysis and determine like when I'm actually producing the program that actually these types are the same, and I can just change the types, right? Mm-hmm. I don't have to just leave it to this thing is supposed to be universally true about the entire program. I can actually localize some of it and get rid of, some of those casting between types. It's like definitely possible. Mm-hmm. It's just more work. And so the extensions I'd like to see are largely just helping out with some of the performance of things like that. So it makes it a little bit easier for, implementers, in the future.
Now, Oscar, when you say work, the work that you're doing, mm-hmm. Now we're not foisting that on the end user, right?
No, not at all.
It's not like I may have to slightly write my Python program a little bit different, so I'm not using multiple inheritance. But when you're talking about the work, you're talking about language implementers, compiler implementers.
Yeah, that nerd sitting in the corner, spending his weekend trying to write a compiler.
I wanted to make sure anyone who's listening, who's wants to be an end user and compile down to a WASM target, they're not rewriting their program because of this. Yeah,
no, definitely not. It largely is going to be. It's the thing that we always laugh about, even on this show, right? Is that WebAssembly, for all intents and purposes, the way to think about it is, it's the same as like an x86 or an ARM, and we're all super excited about it, but that's really the way we should be thinking about it. End users should never have to care about any of this whatsoever. Like it's all just the people who are implementing, but that's a lot of the people who are listening are just they're nerds just like us, and they care about all these things because it's fun and fascinating to think about, So that's the situation we're in right now.
There's been work on ahead of time compiling for JavaScript in the community as of late. Is there anything that can be done with garbage collection to make that burden a little easier to take on for the implementers?
Probably not in that situation. I'm assuming you're referring to Chris Fallon's WeVal work and Starling Monkey.
There's other folks in the community that are building ahead of time JS to WASM compilation.
Yeah, I know there's been a few projects. I guess the answer is it's going to depend a lot on the implementation approach. So on the approach of compiling an existing interpreter or runtime for JavaScript or say Python or something to WebAssembly, and then kind of bundling your JavaScript, Python, whatever program with that and running it, that's not going to be able to really take advantage of WASM GC because the runtime has its own garbage collector, and they're so tied together that you really need something separate. If you're doing kind of a greenfield project of compiling JavaScript to WASM, then this makes sense to kind of leverage, and then you wouldn't have to implement a garbage collector that would go along with. Does that answer the question?
It does. Yeah, absolutely.
Yeah. Okay. One thing I'd throw in there too, right? And this could be its own podcast episode, but the viability of JavaScript to WASM compilers, I think is a really interesting topic because there's a ton you can do to make the JavaScript go faster for sure. But it's like, can you ever truly get away with doing a ahead of time JavaScript to WASM compiler? Like the thing I always think about is like eval, right? It's like since I have that, I have to have a full I have to have a full runtime that I have to compile in there anyway, right? And so I think it'd be really interesting to get some folks working on the JS to WASM ahead of time compilation on the show.
That's pretty cool. Nick, I want to give you a moment of time just to kind of cover topics that you see in the WebAssembly community that you're particularly passionate about. We've talked about garbage collection, but I know that you work on a lot of different things. What are you working on right now that you're particularly excited about?
Yeah. Well, most of my time right now is going towards GC and fixing bugs that we found mostly via fuzzing. So I guess that's a big thing that I'm a fan of is fuzz testing, which is basically the idea of throwing pseudo-random input at something and seeing the ways in which it fails. And so that pseudo-random input might be literally just like random bytes. And then you test if your parser has any crashes or whatever, or you might, generate pseudo-random WebAssembly programs and then run those through your compiler and make sure that that doesn't, that produces the same result in your engine as it does in, V8 or SpiderMonkey or something, right? So we use that a lot for WASM time for correctness and safety assurances. Other stuff we're doing is been trying to make WebAssembly a better target for embedded programming. So WebAssembly has the idea of this linear memory, as we talked about, kind of at the start of the show, and that's divided into pages. And a page is 64 kilobytes in size, which is pretty large when we're talking about the embedded world, maybe larger than the amount of memory that's available for, WASM to run, right? And so I'm the champion of the custom page size proposal for WebAssembly, which allows you to customize the page size and say, actually, the page size is 1 byte, right? And then so you say, I want a memory of 100 pages in size. Well, it's just 100 bytes, right? And so now you can basically perfectly size your memory to exactly what you have available on this device. And it's all standards track and is implemented by I think 5 or 6 different WebAssembly runtimes at this point. So, it's a thing, it's happening, it's real. Just landed support for it in LLVM's linker, which is used by Rust and Mscripton and all of that stuff.
Yeah, work like that is the gateway to doing firmware for hardware, for example, in WebAssembly, which I know there's a Google effort to do that. There's a few different efforts out there to implement like that. So yeah, it's an advancement to the state of the art for the whole industry, which is a cool thing. Any other things going on that you're particularly passionate about?
Well, just something that I kind of missed my chance to bring up earlier, but we mentioned about how the runtime, you can choose which collection algorithm might work best for your use case where you're running WebAssembly. We are implementing 3 different collectors in WASM time. So there's going to be the null collector that exists today, and that does not collect garbage. It just keeps allocating till you run out of space. Exactly. And when you run out of space, it crashes. The other that we have right now is a deferred reference counting collector. So it's reference counting. It won't collect cycles. It has better latency, worse throughput. But the deferredness, I don't have time to get into it now, but basically it helps speed up some of that throughput and removes a lot of those incref, decref operations that would otherwise be there. And then the third one, which has not been implemented yet, will be very soon now that I'm pretty much done with finding all these fuzz bugs, is just a classic semi-space copying collector. This was, I think, maybe the very first garbage collection algorithm that was developed. It was developed for a Lisp, and basically you divide your heap in half, you allocate up to the halfway point, and then at that point, you find all the things that are live. And when you find them, you move them to the other half of it. And then from there, now you allocate until that half is full. And then you move them back to the first half, right? And so this has very good properties like you can bump allocate, which is a very fast method of allocation where you just advance a pointer essentially. And then you can also, you don't have expensive barriers and stuff like that. You have pretty good collection times. The big downside is you're cutting your heap in half. But like, as long as you don't actually hit that, it's pretty good. And it provides a nice balance of like fast allocation and not crashing when you run out of memory, and being able to continue going. So like, I think even for, function as a service use cases, this is probably what you want, rather than just kind of like saying, you're done.
Yeah. All right, Nick, I have one parting question for you. Will Java allow me to catch the out of memory exception that might occur when using one of these special collection algorithms?
WebAssembly won't let you do that because running out of memory doesn't result in an exception in the WebAssembly language. But yeah, I think in JavaScript, I think it does. Does it do it in Java as well?
I don't know.
Oscar, you're going to be on Galad's naughty list before long, my friend. Oh, well. With that, on that wonderful note, we're ticking down to the end here. I really thank you, Nick. That was a great discussion. We brought garbage to the masses, and I'm very proud of that. Big thank you.
Away, baby.
There you go. Thank you, Oscar and Matt. It's a big application world out there, folks. It's time to unleash the power and promise of WebAssembly. For Nick, Matt, Oscar, and myself, thanks for listening in. Be sure to hit that like and subscribe for future WebAssembly news and views. And take care.
Yeah, thank you.
Thanks so much for having me.